What is database normalization? While studying about databases, you come across terms like normalization. Now here we're going to discuss it in brief. Basically, normalization is the process of reducing duplication in a database. Now we have this while we're discussing about flat file databases. The ultimate goal of normalization is eliminating duplicate data entirely from the tables in the database. These duplicated data can cause a database to be occupying more disk space. The bigger issue is consistency. Duplication creates the risk of data corruption when information is inserted, updated, or deleted by having a particular piece of information in more than one place. Database normalization can essentially be defined as the practice of optimizing table structures. One of the more complicated topics in the area of database management is the process of normalizing the tables in a relational database. The underlying ideas in normalization are simple enough. Through normalization, we can design our relational database as a set of files that, 1, contains all the data necessary for the purposes that the database is to serve, 2, have as little redundancy as possible, 3, accommodate multiple values for types of data that requires them, 4, permit efficient updates of the data in the database, and 5, avoid the danger of losing data unknowingly. Now basically, normalization can be viewed as a series of steps designed, one after another, to deal with ways in which tables can be too complicated for their own good. The purpose of normalization is to reduce the chances for anomalies to occur in a database. The definitions of the various levels of normalization illustrate complications to be eliminated in order to reduce the chance of anomalies. Normalization is a formal process. It's been around since the early 70s when Boyce-codd proposed the first normal form, or 1NF. Codd later defined 2NF and 3NF. Now since that time, several higher-level normal forms have been defined. 4NF and 5NF are often used only in the academic sense, because queries against real-world data in a 4NF or 5NF schema contain excessive numbers of joins and require extensive use of views. 6NF is fairly new and contains rules specific to temporal data. As one progresses from 1NF to 5NF or even 6NF, the data modeling requirements become more strict, and each new form provides a lower degree of duplication than the preceding form. Now we'll talk in brief about these normal forms in our upcoming lessons.